Okay, we're going to look at how do we find the trig ratios on the unit circle for the axes and when we count by 45 degrees. That's also whenever we count by pi over 4. Okay, so that's in radians. All right, well, the unit circle is a circle with radius 1 that we draw on the x and y axis. So if I have my x and y axis, I draw a circle, and the radius is 1. So this radius is 1 unit long. Okay, now we're going to talk about the reference angle, the angle that gets it back to the x-axis, this angle. And we're trying to find the trig ratios for these angles, okay? So if I were to drop the altitude and make a 90-degree triangle, well, this triangle has a base of x and a height of y, because this point on the circle is at some x, y coordinate. Okay, well, so this x and y, we're going to come back to that. First, let's think, okay, what's the sine of theta? Well, the sine of this theta would be the opposite over the hypotenuse, so y over 1. Well, y over 1 is just y. The cosine of theta would be the adjacent side over the hypotenuse, so x over 1 is x. And the tangent would be the opposite, the y, over the adjacent x. Okay, if we keep going along with that, the cosecant of theta, that's 1 over sine theta. So that's just 1 over y. And so the secant of theta, by the same thinking, would be 1 over the cosine, so this is 1 over x. And the cotangent of theta will be x over y. So now I can think about any xy coordinate as just, well, x is cosine, y is sine, so this is just cosine theta, sine theta for any coordinate on the unit circle. Alright, let's build the unit circle. Alright, we have the y-axis and the x-axis perfectly straight. Okay? Alright, so the radius of this circle is 1. So at each axis, this is 1 unit away. So this is at the point 1, 0, 0, 1, negative 1, 0, and 0, negative 1. Alright, so each of these points, how many degrees or radians are they around the circle? This would be at 0 degrees, or I could say 360 degrees. This is at 90 degrees, 180 degrees, 270 degrees. In radians, this would be 2 pi or 0 pi. Pi over 2, pi, and 3 pi over 2. Alright, now what we're going to do is we're going to count by 45 degrees to find some more points on this circle. Okay, so if I go 45 degrees, I'm right in between 0 and 90. Right? So I've gone 45 degrees. If I go So this is at 45 degrees or pi over 4. So we can count by 45s or by pi over 4. Okay? So if I go another 45, I'm at 90, or pi over 2. Right? So pi over 4, 2 pi over 4. 2 pi over 4 reduces to pi over 2. That's where that comes from. Keep counting. We're at 3 pi over 4. I'm sorry about that line. So this is at 3 pi over 4. And if we just added 45 degrees to 90 degrees, this is at 135 degrees. 4 pi over 4 is pi. So down here we're at 5 pi over 4. Or 225 degrees. 6 pi over 4 is 3 pi over 2. There's 7 pi over 4, which is 315 degrees. Just adding 45. And you add 45 to 315, you're back at 360. Or add pi over 4 to 7 pi over 4, you're at 8 pi over 4, which is 2 pi. So now, these points, the 1, 0, 0, 1, negative, those are all easy to find. I'm interested in what are these points. Okay, if I count by 45 degrees. So what I do is I zoom in and I imagine that I have a triangle right here. Okay? So I'm going to imagine this triangle. I'm going to drop a 90-degree angle. This is 45, so this other angle must also be 45 degrees. The radius of the unit circle is 1, so that's my hypotenuse of this right triangle. And so by special right triangle rules, the sides of a 45, 45, 90 are the hypotenuse divided by the square root of 2. Okay, but I can't leave the square root of 2 in the denominator, right? So I have to simplify that. I've got 1 over the square root of 2. To simplify, we're going to have to multiply by the square root of 2 over square root of 2. So that gives me the square root of 2 over 2. The sides, or the legs of a 45, 45, 90 are equal, so this is also square root of 2 over 2. Alright. So now, thinking about this point, its height, or the y, is whatever the height of that triangle was, which was square root of 2 over 2. And it's the length this way, the x, is square root of 2 over 2. So this point is at square root of 2 over 2, square root of 2 over 2. And then we have the same triangle all around. So all these points, they'd all be the same lengths. But this is in the second quadrant, it's in a negative x direction. So this point is at negative square root of 2 over 2, square root of 2 over 2. This point right here is at negative square root of 2 over 2, negative square root of 2 over 2, and so on. Square root of 2 over 2, negative square root of 2 over 2. Okay, so now let's find a few of the trig ratios at these coordinates. First, I'm going to do the sine of 3 pi over 2. That is a 3, just so you know. Okay, so the sine of 3 pi over 2. Well, my first step is going to be to look for the ordered pair. Look for the ordered pair at Let me redraw that. At 3 pi over 2. Okay, so I go to my unit circle, and here at 3 pi over 2, its ordered pair is 0, -1. Okay, now I just go back to my ratios and I say, okay, the sine of theta is equal to y, so I just find the y value. So find its y value, which is -1. So the sine of 3 pi over 2 is -1. Okay, so let's try that whenever we're looking for the cotangent of 315 degrees. Okay, so I find the coordinate at 315 degrees. The coordinate is square root of 2 over 2, negative square root of 2 over 2. I know that the cotangent is the x value over the y value. So I have square root of 2 over 2 divided by the negative square root of 2 over 2. We have the same thing being divided, like in the numerator and the denominator, one of them is just negative. So these two things just cancel each other, and my answer is, again, -1. Okay, let's try to find the tangent of 180 degrees. So the tangent is the y value over the x value. At 180 degrees, that'd be 0 over -1. If 0 is in the numerator, that's fine. So we have that equals 0. Now, if 0 is in the denominator, like if you wanted to take the secant of pi over 2, well, the secant is 1 over the cosine, so that's just 1 over x. I go to pi over 2. 1 over x, well, that'd be 1 over 0. Whoops. And if you divide by 0, that's undefined. Alright, let's just try a couple more examples and that'll be it. So, the cosine of pi over 4. Find pi over 4. It's right here. The cosine is the x value. So the x value of pi over 4 is square root of 2 over 2. If I wanted to find the cosecant of 5 pi over 4, the cosecant is 1 over the sine, so this would be 1 over y. At 5 pi over 4, that's 1 over this y value, negative square root of 2 over 2. Okay, if I'm dividing by a fraction, you just flip the denominator and multiply. So 1 times 2 over negative square root of 2. Well, 1 times that is just going to be negative 2 over square root of 2. I can't leave the square root of 2 in the denominator, so I have to multiply by the square root of 2 over the square root of 2, giving me negative 2 square roots of 2 over 2. The 2's cancel each other, and I get that the cosecant of 5 pi over 4 is negative square root of 2. Okay, so we can use all this to find all the trig ratios for anything on the axes, or if we are counting by 45 degrees.